So today we are going to be approximating the value of square roots without a calculator. Now, this tends to be a little bit hard because it takes a little bit of work, but what really helps you will be knowing your list of perfect squares, okay? Because remember, the definition of a square root is what number times itself equals that inside number. For example, the square root of 9. What number times itself equals 9? 3. So the square root of 9 is 3. But if you're given something like the square root of 51, what number times itself equals 51? That one's not such an easy problem because there's no whole number that if you multiply it times itself equals 51. All right. Now, if you have a calculator, this is a very easy problem, right? The square root of 51, turns out it's 7.141428. Okay, so it's this really long decimal. All right. Now, could I have known that without using my calculator? I can get pretty close if I do some basic math. And here's what we do. First off, that square root of 51. First, if you know your perfect squares, think about which two perfect squares are around the square root of 51. So, for example, if I'm looking down my list of perfect squares here, the square root of 51 would be right in between here, the square root of 49 and the square root of 64. All right. Now, how does that help me? Well, the square root of 49 is a little too small, and that's 7. The square root of 64 is a little too big, and that's 8. So that means this has to be somewhere between 7 and 8. So it's got to be 7 point something. And if I take that a step further, 51, it's closer to 49 than it is 64. So that means the square root of 51 has to be closer to the square root of 49, which is 7. So this, to the nearest whole, is about 7. All right? But I think we can do a little bit better than that. All right? So now we're going to get a little bit closer. And in order to do that, we're going to have to do a little guess and check and multiply. Because remember, we want to know what times itself equals 51. We know it's got to be between 7 and 8. And we know it's closer to 7 than it is 8. So we can do a little guess and check. For example, let's try 7.2. Okay? So if the square root of 51 is about 7.2, that would mean 7.2 times 7.2 would equal 51. Now we know it's probably not going to equal exactly, but let's see how close we get. Okay? 2 times 2 is 4. 2 times 7 is 14. Drop down my 0 for my placeholder. 7 times 2 is 14. Carry the 1. 7 times 7 is 49. Plus 1 is 50. And then add them up. 4, 8, 1, 5. And there's 2 digits behind the decimal in my original problem. So that means there's 2 digits behind the decimal in my answer here. So I got 51.84, which is not that far away from 51. It's a little bit big, but I mean, it's fairly close. 7.2 is not a bad estimate, but let's see if we can get closer. Let's go a little bit smaller. Since this is a little too big, we'll try 7.1 now. All right, let's see what we get. So 7.1 times 7.1. 1 times 1 is 1. 1 times 7 is 7. 0 for the placeholder. 7 times 1 is 7. 7 times 7 is 49. And now add them up. 1, 14, carry the 1, 10, carry the 1, 5, and 2 digits behind the decimal in the original problem. So there's going to be 2 digits behind the decimal in my answer. So 50.41. Okay, so here's the good news. I'm pretty close, right? 7.2 times 7.2 gets me a little bit bigger than 51. 7.1 times 7.1 gets me a little bit smaller than 51. So the square root of 51 has to be between these two. All right. Now, which is the better approximation, 7.1 or 7.2? Well, which one's closer to 51? Like this one right here, this is 0.84 away from 51. Now, this one's a little bit smaller, but this is 0.59 away from 51 because I would have to add 0.59 to get this to equal 51. So notice, in this case, this one's closer, so 7.1 is the better approximation than 7.2. So we could say the square root of 51 is about 7, or if we wanted to get even closer, more accurate, we could say it's about 7.1. All right. And again, if we use the calculator to check, notice, remember what we got? 7.14? 7.1, it's pretty close. All right, let's do another one so we could see it again. All right. This time, we'll do the square root of 12. All right. So, just like last time, what we're going to do is look at our list of perfect squares and think about which two perfect squares is the square root of 12 between. And if you notice, it's going to be right here. All right, it's going to be right between the square root of 9 and square root of 16. All right. Now, is the square root of 12 closer to the square root of 9 or the square root of 16? Well, 12 is 3 away from 9, but it's 4 away from 16. So it's closer to this one. So we can say the best approximation for this as a whole number would be about 3. All right, it's kind of in the middle because it's 3 away from 9 and 4 away from 16. But even though it's in the middle, it's closer to 3 than it is 4. All right. Now, just like last time, I think we can do better than this. So let's try approximating this to the nearest tenth, just like we did last time. All right. So if we do that, what we're going to do is, first, we're going to have to pick a number to multiply times itself to see if we can get 12. Now, remember, we said it was between, right in between 3 and 4, a little bit closer to 3 than it is 4, so it's kind of in the middle. So 3.5 is right in the middle. Let's try 3.4. Because it's right in the middle, but it's a little bit closer to 3 than it is 4. So that's a good one to start with, and see if we can get close to 12. All right, so let's multiply this out. 4 times 4 is 16, carry the 1. 4 times 3 is 12, plus 1 is 13. 0 for the placeholder. 3 times 4 is 12, carry the 1. 3 times 3 is 9, plus 1 is 10. Add them up. We get 6, 5, 1, 1. I've got 2 digits after the decimals in my original problem, so I'll put 2 digits after my decimal in my answer, and I get 11.56. That's not that far away from 12. It's a little bit small, but it's fairly close. So we need to try a little bit bigger because this is a little small and see if we can get closer than that. So a little bit bigger than 3.4 would be 3.5. So let's try 3.5 times 3.5. Because remember, our goal is what number times itself equals 12. Maybe this one will be closer. Maybe it won't be. We'll find out. 5 times 5 is 25. Carry the 2. 5 times 3 is 15. Plus 2 is 17. 0 for the placeholder. 3 times 5 is 15. Carry the 1. 3 times 3 is 9. Plus 1 is 10. Now, let's add up our numbers here. 5, 12. Carry the 1. 2, 1. And again, 2 digits after the decimal in my original problem. 2 digits after my decimal in my answer. All right. So notice, we actually did come pretty close to 12. 12.25. Okay. So the question becomes, which one's actually closer to 12? We know this one is 0.25 away. It's actually pretty close, right? Now, this one over here is actually 0.44 away. You would have to add 0.44 to this to get 12. So notice, in this case, this one's actually closer. So that means 3.5 is the better approximation. So if you want to round the square root of 12 to the nearest whole, we'd say 3. But if we want to round to the nearest tenth, it's going to be 3.5. And that seems odd because 3.5 would round to 4, right? But let's check it on the calculator to see why that is. Square root of 12 comes out to 3.46410. So notice, if we wanted to round this to the nearest whole, now we can see why it was a 3. It comes out really close to 3.5, but it's a little less than 3.5. It's 3.46, so it would round to 3. But if we rounded to the 10th, we actually would get 3.5. All right? But notice, we found all of this without a calculator at all. Okay? You do have to know your perfect squares, but most of them are basic multiplication tables. All right? And you do have to do a little bit of work. All right? Remember, your goal is to think about what times itself will get me that number, or at least really close. All right? And you always want to get the one a little bit bigger and the one a little bit smaller, and then figure out which one is closest to the number you're trying to get. All right? So Hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math and I will see you next time.